So here we have 2015 question 7. This is Lebensjahr ordinary level, and this is a question on sequences and series. So we're told the first three patterns in a sequence of patterns are shown below. So this is the first one, the second one, and the third one. I've just drawn them out. So we are asked to draw the fourth in the sequence. So what I would say is we have 1, 2 rows here, 1, 2, 3 rows here, 1, 2, 3, 4 rows here. So in this one, we're going to have 1, 2, 3, 4, 5 rows. In each row, there's 1 in the first row, 2 in the second row, 3 in the third row, 4 in the fourth row. So the first one has 1, the second one has 2, the third one has 3 black triangles, then 4, then 5 black triangles. So that's the fourth pattern in the sequence. So then we're asked to fill in the table. So they've already actually filled in the number of black triangles in the first. So in the first, say if we just have a look at that, we can see clearly that there's 3 black triangles. There's 1 white triangle in the middle. So, and then the total number of small triangles is 4. So then in pattern number 2, so say if we wanted to just, so we have 1, 2, 3, 4, 5, 6. But we can see that we already had 3 black triangles from the first one, which we knew, and then it's just adding on another 3. So there's going to be 6, and then there's going to be 1 white triangle that was also in pattern number 1, but then we're adding on an extra row. So there's going to be 3. So there's going to be 9 so there's going to be 9 altogether. And then this one, so this part from here to here was already in this triangle. So the only thing that's added on is, so there was 6 triangles in the one before. So what's added on is 1, 2, 3, 4 more triangles, black triangles. So there's going to be 10 black triangles altogether. And there was 3 white triangles from the last one. So there's 1, 2, 3 more. So there's going to be 6 white triangles. So altogether there will be 16. So then in pattern number 4, from the up until the last row, we have already counted in our last one. So there are 1, 2, 3, 4, 5 more black triangles. So there's 15 black triangles, and there was 6 white triangles from the last one. So there's 1, 2, 3, 4 more black triangles. So that's going to give us 10. So the total number of triangles is going to be 25. We're asked to also fill in for pattern number 5, which we haven't drawn, but we can see that in the total number of black triangles, so in each time in pattern number 1, we have 3 black triangles, and then we're adding on an extra row. So we're adding on, so the extra row we're adding, so say in pattern, say if we'll just look at pattern number 1, so we have 3 black, and then we're adding on an extra row of 3, so we're adding on 6. So we're getting 6 altogether. Then the next one, we're adding on an extra row, so it's plus 3. Then we're adding on plus 4 black triangles to get to this one, so we get 10. Then to get to this one, we're adding on plus 5 black triangles, so we get 15. So to get to the next one, we're going to be adding on so it'll be 6 black triangles, so it'll be 21. So that'll be 21. And then if we have a look at how the white triangles are changing, so we're adding on 2 here, then we're adding on 3, then we're adding on 4. So in the next one, we're going to be adding on 5. So it's going to be 15. So then altogether, there's going to be 36 triangles altogether in a pattern number 5. And then we're asked to show that the number of black triangles form a quadratic sequence. So what I'm going to do is I'm just going to write out, so we have 3, 6, 10, 15, 21. So if we have a quadratic sequence, there's going to be a constant second difference. So in a quadratic sequence, there is going to be a constant second difference. So in this case, we can see that, so the difference from 3 to 6 is 3. 6 to 10 is 4, 10 to 15 is 5, and 15 to 21 is 6. So the difference between each of the terms is called the first difference. But if there's a constant first difference, it's a linear or an arithmetic sequence. But we can see that the difference between all the terms is not the same. So it's not a linear or arithmetic. But then if we can look at the difference between the differences. So here's a jump of +1, then another +1, and then +1. So the difference between the first differences is called the second difference. And if we have a constant second difference, well, then we have a quadratic sequence. So we can see here that we have a constant second difference. So we can see that we have a quadratic sequence. And then we are asked to show how many black triangles are in the 9th pattern. So if we haven't got the general term of the number of black triangles yet, but I'm just going to write out kind of the number of, so in pattern number 1, number 2, number 3, number 4. So we have 3 black triangles, then we have, or actually I'll go down in rows, it might be handier. So the number of black triangles in pattern number 1, we have 3. In pattern number 2, we have 6. Number 3, we have 10. 4, we have 15. And then 5, we have 21. So they didn't ask us yet to actually get the general formula or general term. So I think they actually want us to work it out kind of ourselves. So we can see that if we're looking to get, so we know it's a quadratic sequence, but so it's going to be a constant second difference. So from 3 to 6, we get 3, 4, and then 5, and then 6. And there's going to be a constant difference of 1 between each of the differences. So that means that the differences are going to increase by 1 each time. So to get to the next one, to get to number 6, we're going to have to add on 7. So that gives us 28. To get to number 7, we're going to have to add on 8 to 28. So that's going to give us 36. To get to pattern number 8, we're going to have to add on 9 to 36, and that gives us 45. And then to pattern number 9, we're going to have to add on 10. So that's going to give us 55. So the number of black triangles in the 9th pattern, which is D part 1, is going to be 55 black triangles in 9th pattern. So then we're asked to get how many white triangles are in the white pattern. So we could do this exact same thing for the white triangles. So in the first one, we had 1, then we had 3, then we had 6, 10, and 15. So the difference here is +2, then it's +3, then it's +4, then it's +5. So difference increasing by 1 each time. So then to get to the next one, it's going to be +6. So it's going to be 21. Then to the next one, sorry, that's +6. And then +7. So it's going to be 28, and then it's going to be +8, so that will give us 36, and then +9, which will give us 45. So we get that there are 45 white triangles in 9th pattern. And then they ask how many small triangles altogether are there in the 9th pattern. Well, the total number of triangles is equal to the number of black triangles plus the number of white triangles. And if there's 55 black and 45 white, well, then the total number of triangles will be 55 plus 45. So it'll be 100 triangles altogether. So 100 in total. And then we were asked to write an expression in n for the total number of triangles in the nth pattern. So so we got that. So they were asking us to write an expression in n. So we're going to have to kind of look at the total number of triangles. So in the first one we have 1. So in pattern number 1 we have 4. In pattern number 2 we have 9. In pattern number 3 we have 16. Then in pattern number 4 we have 25. In pattern number 5 we have 36. So we can see that these are all square numbers, but it's not the pattern number squared, because if we had n squared, here's pattern number 1, that's number 2, number 3, number 4. In pattern number 1 is 2 squared, pattern number 2 is 3 squared to get the total number of triangles. So if we had the pattern number and then plus 1 squared would give us the total number of triangles, because say in pattern number 1 it's not 1 squared that gives us the total number, it's 2 squared. So 1 plus 1 gives us 2 squared. So if we want to check that, in the first pattern the number n is 1, so 1 plus 1 squared, so that'll be 2 squared, so that'll be 4. In the second pattern that'll be 2 plus 1 squared, so that'll be 3 squared, so that'll be 9. So an expression in n for the total number of triangles in the nth pattern we can write as n plus 1 squared. So that would be an expression in n. And then we were told in part F, so the number of black triangles in the nth pattern is given by the formula. So a half n squared plus 3 over 2n plus c. So find the value of c. So what I can do is get the number of black triangles in the first pattern, which is 3. So in pattern number 3, n equals 1. In pattern number 1, we have the total number so it was the number of black triangles. We have 3 black triangles in the first pattern. So I can make sub in n equals 1 and let that equal to 3. So a half 1 squared plus 3 over 2, 1 plus c is equal to 3, because there's 3 black triangles in the first pattern. So that will be half plus 3 over 2 plus c is equal to 3. And then we can add a half and 3 over 2 together and we'll get 2 plus, so we get 2 plus c is equal to 3. So c is equal to 3, subtract 2, so c is equal to 1. So the value of c is equal to 1. So and then it says, so we're after getting that then the general term for the number of black triangles. So black, so we got it, we were told in the question that it's a half n squared plus 3 over 2, 3 over 2n plus c, and we got that c is equal to 1, so it's a half n squared plus 3 over 2n plus 1. So that's the number of black triangles, and we got that. So we were asked to use our answers in E and F. So this was our answer from F, and our answer from E was we were asked to find an expression for the total number of triangles. So we got that was n plus 1 squared. So that was our answer for E and F. And then in part G, we were asked to use our answers from part G and F to find the number of white triangles. So the total number of triangles is equal to the number of black triangles plus the number of white triangles. So that means if we wanted to get the number of white triangles, that would be equal to the total minus the number of black triangles. So the total we got was n plus 1 squared, and that's minus the number of blacks, which is a half n squared plus 3 over 2n plus 1. So if we multiply this out, which we already did, we got that it was n squared plus 2n plus 1, and that's minus a half n squared plus 3 over 2n plus 1. So that's n squared plus 2n plus 1 minus a half n squared minus 3 over 2n minus 1. So n squared minus a half n squared, so that's a half n squared 2n minus, that's like 1.5, so that's a half n. Then 1 take 1 is 0, so that's just after going in Zoom. So that is my answer for the number of white triangles. And then one particular pattern has a total number of 625 triangles. We're asked to find the number of black triangles and the number of white triangles. So we have the formula for the total number of triangles is n plus 1 squared. The formula for the number of black triangles is a half n squared plus 3 over 2n plus 1, and the formula for the number of white triangles is a half n squared plus a half n. So firstly, we're just going to have to get the value of n. So one particular pattern has a total, so we're going to have to let the total number of triangles equal to 625. So what we're going to have to do is we're going to have to get the square root of both sides. So the square root 625, we get 25, so n plus 1 is equal to 25. So n is equal to 25, take 1, n is equal to 24. So we have to just get the number of white and black, or we can just get the number of white and then subtract from the total to get the number of black. So to get the number of white, our formula is a half n squared plus a half n. So a half 24 squared plus a half by 24. So if I'm just to plug that into my calculator, a half 24 squared plus a half 24. So then I get that there's 300 white triangles. So the number of white is 300, but the number of black will just be the total minus the number of white instead of having to work that out. So the total is 625, so that would be minus 300. So that will give us the number of black triangles. So the number of black triangles is 325. So the number of white is 300 and the number of black is 325. And that is my answer for that question.